Recording. Welcome to Calculus of the PM. I'm your host, Mr. Sindel. 8.1 integral is a net change. Let's see here. Linear motion. And the reason why I include this, the AP final exam often has questions involving a given velocity function. We need to understand something. We played around with these before. It was on the review too from chapter 6 even. From this, you will be able to find the acceleration. What's the acceleration of a given velocity? The derivative of the velocity function. And the displacement of the object, or the distance traveled by the object. They're sometimes different. People in physics know what I'm talking about, right? Keep in mind, displacement is the net change in position from one object to the other and is found by integrating the velocity function. If you're asked for the distance traveled, you need to find the total distance traveled without regards to direction. This means you need to integrate the speed function, which is just integrating the absolute value of the velocity function. It's easy to say and it's easy to do on a calculator, absolute value, integrate. But if you're doing it by hand and it's a non-calculator section, well, there's more to it than that. Now, real quickly to review, especially for those who's not physics. You're not physics. Who didn't take physics or is not taking physics? Just KZ? Is that all? Oh, you didn't either. So if I say I start here and I go east 100 meters, travel back 80 meters this way. Displacement versus total distance. My displacement, where I started and where I ended up, went 20 meters to the east. Does that make sense? I'm more or less pointing at you ladies, right? That's displacement, where I am from the starting. Net change in position of an object. And if you integrate whatever timeline, it was straight up. That's what you'll get, is the 20 meters. If I ask for total distance, you would say 180 meters traveled, right? Because you went 100 one way, 80 the other way. So you would have to use the velocity function and see, okay, I start here. If I had the function, I'd get a 0 here, because how else can you change directions? You've got to stop going east and then start going west, and then go up to this final time. So you'd have to find your zeros if you're doing this by hand, and calculate the area above and the area below the x-axis is two different, x-axis is two different chunks, and then add them together, absolute values, right? That's your total distance. Calculator is even easier, though. You just put the flat brackets around it. But let's just see here. Interpreting the velocity function. This down here shows the velocity. Now, the reason why I have 7.1 is because the old textbook used to be chapter 7. But we know this. The derivative of the position, S, the textbook uses as position, is the velocity. Okay, velocity is the derivative of a position function. And it's given by this function, t squared minus 8 over t plus 1 all squared. Okay? And it's for a particle moving along between 0 and 5, so there's no problems about the -1 here. Who cares, eh? Describe the motion. Well, if you graph that on your calculator, you get a picture something like this. Now, let's see if we understand this, and physics people might. Now, keep in mind this is velocity, so if you want to jot that down and that this is t on this axis, right? I guess I got to disappear here. And I did give units. This is velocity in centimeters per second. Put this over here. And this is time in seconds. Okay, so what's happening at the start, guys? Let's just say the velocity is going north or south. Positive being north, negative being south, okay? At time 0, what's my velocity approximately? Negative 2-ish, right? So that means I'm going south at 2 centimeters per second. Does that make sense? Then what happens just after 1 second? I was going south, stop, turn around, Now I pick up speed, but I'm speeding up, going north. Very slowly going north at 2 seconds. I'm going about 1 centimeter per second. At 3 seconds, I'm going just in the ballpark of 2 centimeters per second. 4 seconds, you can see, right? 5 seconds. That's your speed, right? Now, that's reading the graph. Do you see unit-wise? If you found the slope of the tangent line right here, what is the slope's units? So at 4 seconds, what's the slope? What is the unit of slope? Rise over run? Centimeters per second divided by? So seconds squared, right? Centimeters per second squared. That sounds like a acceleration. Hey, this makes sense, doesn't it? The derivative of velocity gives you acceleration. If I was to find the area between 3 and 5 seconds, I'd have this kind of thing that looks like a triangle with a rectangle, right? Just think rectangle. If I was to do the area of a rectangle here with these units, the height, centimeters per second, times the base, seconds. What is the unit you get when you do areas? Just centimeters, which makes sense because we get displacement, right? Yeah? Okay. So the integral will give you units of centimeters that matches with displacements or net distance from the start. Okay. Let's take a look at this one here. So we could describe that. I didn't write it out, but we could describe it, right? You know what, though? I wasn't reading that graph very well. I see now 0 to 5, 0, 5 here. It doesn't really change what we talked about. Negative 10 to 30. Somebody said negative 8 or something like that. This is negative 10. Oh, didn't need to do that. And this is 30. Here. So when we were saying 1, 2 centimeters, we actually meant 5, 10, 15, and so on, okay? I didn't read the graph very carefully there. Okay. Still, same idea. Velocity is equal to 10 minus 2t. That function is the velocity in meters per second of a particle moving along the x-axis. That just means it's not going curving to the left and right. It's just going straight ahead or straight backwards between 0 and 9 seconds using analytic methods. So that means by hand. Determine when the particle, not by graph either, not graphical methods, when the particle is moving to the right, to the left, and stopped. So we're going to assume in a velocity function, to the right means positive values, negative values, to the left, 0 is stopped, velocity of 0. So, how do we do this? We've got a velocity function, so I'd suggest starting to factor. It's a pretty easy function. Factor this out, and you got, oh, come on, guys. You got, I do this because it's easier to see where the 0 is. So I'm going to just do a quick, you wouldn't necessarily have to do this. I know it's between 0 and 9, so I'm going to stop at 9. 0, and I see that 5. Okay. I'm just doing this to organize my thoughts. We got positive 5 times 5 minus t. So obviously we've got a 0 at 5. Between 5 and 9, 5 minus 6, for example. What do we have? Negative values. Positive values here. That means it's going to the right. Well, that's our first question, is it? Moving to the right, to the left, and stop. So it's going to the right on what interval? To the right on the from 0 to 5 since, I guess, seconds, 0 seconds to 5 seconds. How do I know that? Since v is positive. Yeah, well, I gave the interval, but yes, you're right. On this interval, as Tristan mentioned. Incomplete sentence, but I'm going to do this one here. Stopped at t equals 5 seconds since 0 meters per second, 0 centimeters per second. We could put any unit there, it's still 0, right? But I'll put the meters per second. And to the, I should put to the left from 5, oh, not equals, seconds to, on the interval, I guess, to the left on the interval from 5, that'd be a better statement. On the interval from 5 seconds to, what is it, 9 seconds. Loose. And I justify that since is less than 0, it's 8 on that interval. Okay. When you're asked to justify, you generally need to make a statement like this, since something's less than, greater than. This is not true justification, but I suggest you use sign analysis throughout to organize your thoughts. It's way quicker, and it's less confusing for many people anyways. So that's why I do that. So, I'm forgetting here. That's good. Find the particle's displacement for the given time interval. So the displacement is just doing the straight up integral of the function, right? So, displacement is from A to B of that velocity function. Now we have specifics. We're from 0 to 9. Yeah. And what was it? 10 minus 2t. Yeah. I'm all ears, young lady.
I finished.
Now, I did the work. You guys did the work too, I hope. You had enough time. This means to the right. Positive 9, right? It ends up. It's actually traveled more distance than that, though, right? So, if S of 0 equals 3, what is the final position? Now, there's a number of ways we could think of this. Simple solution. It starts at 3 meters. How far does it move over after 9 seconds? Huh?
6 meters.
What? From its starting point, we didn't know what the starting point was. It's moved over 9 meters though over its starting point. So if it started at 100 meters from Greenwich Village or something like this, you'd say 109 meters. If it started at what we define as 3 meters from a starting point, it will go 9 more meters to the right to 12. I know what you're thinking though.
Yeah.
If 0 was really, but now I'm saying that, yeah. No, that's why I want to clear up. The simple solution. The simple solution is the 3 meters plus the 9 that you actually moved. Is the final position. Displacement is how far you moved over. It doesn't say where you started or where you ended up in relation to any other spot. Position is where you define a spot on some kind of measurement line, right? A number line of some sort. start at 3 meters, you move 9 meters, you're at 12 meters. Position is specific. It's like those value questions where you're given a specific X and a Y. It's like that. Total distance traveled by the particle, though. Total distance is where we got to take all the movement to the right, all the movement to the left. By the way, backtracking here. I said simple solution. If you have a scenario where you haven't got this worked out or you need a calculator, how do you set this up? This is like, we know the displacement, I'll just do it like this, is the velocity from 0 to 9, let's just call this VT, because it's defined as VT, which is equal to, what do we know? We know that S of 0, and isn't that the antiderivative of velocity, right? What came before the original function kind of idea? So this is really S of 9 minus S of 0. Does that make sense? The displacement is equal to the position at 9 minus the position at 0. That's what that means in green. This should look familiar to you, right? You've seen things like this? So we already evaluated what 0 to 9 is for an integral. It's 9 meters. S of 9 is what we're looking for. And we're told that S of 0 is 3 meters. Don't we get the same answer? Yeah, we do. Use the abstract way if. You can't just do it the simple solution, like where I'd expect people to be able to just jump into it. That other one's the fundamental theorem of calculus, part 2. Antiderivatives. The difference in antiderivatives is what the integral is. So, we got to take the distance going to the right and the distance going to the left. And we said, I have it on my previous page here, 0 to 5. It moves to the right. So we're going to get a positive answer for 0 to 5, right? So, you find your zeros, which we've done, and then I'm going to go to the right or the positive movement. So the distance is equal to 0 to 5 of, what is it, 10 minus 2t. Which is equal to, we knew this from before, 10t minus t squared. So let's just jump right into it, right? Because we know the antiderivative? Okay, right. 10t, so 50 minus t squared, so 25. Subtracting 0. 25 meters, and that's in the positive direction. Everything's hunky-dory. Now, the distance to the right you move is 25 meters. Distance to the left. I'm going to leave it as a negative right now, and then we'll use common sense. Or maybe, if we know it's to the left, what's the answer going to come out to be? Negative, right? So does it make sense if I just put the negative sign in front of here? Whatever we get as the integral, we're going to take the opposite sign. That's why I put the minus sign. If you want to do this without a minus sign in front, and then after the factor, if you get negative 20, actually you'll get 16, negative 16. You know to take the opposite sign because it just means you travel backwards. 5 to 9. 10 minus 2t. dt, I forgot that, didn't I? C4. So, this is 9 minus 81. Subtracting 50 minus 25. So, I have negative 9 subtract negative 25. No, what am I talking? I'm doing the arithmetic in my head and I can't do it. Yeah, it is. Subtracting 20. Let's do some arithmetic. I got it mixed up, didn't I? Totally did. Negative 36. Right? Okay, I'll just write it out. It's negative 36. Negative 9 minus 50 minus 25, so minus 25. Negative 36 meters. However, I'm going to take that off because I said negative sign in front of it, because I had that initially here, and I'm squeezing too much in here. Negative 36, right, when I do the arithmetic. So it's actually positive, double negative.
So 90 minus 81 is positive.
Ooh.
Minus
Yes, thank you, kid. I'm applying, you know what I was doing?
16.
Thank you, ma'am. Thank you very much. And I initially said 16. You know what, I got mixed up, I didn't write stuff out, and I was applying the negative sign to the first bracket, not to the second. I have to write stuff out, no different than you guys.
Maybe you should.
I know I should. So this is 9 minus 25, double negative on the 16, thank you so much, meters. So what's your total distance? Add those, right? It's integral of those two added together. So total distance. Now I want to show you something on your calculator, because if it was a calculator question, where am I here though? 25, 35, where am I? 41? Yeah, 41 meters. Okay. Back to this real quickly. So, I'm doing my integral. Why am I doing it there? I'm going to get out of here. That's right. Second function quit. Okay. Math. I don't want to graph it. 0 to 9. Inside the brackets, then I'm going to go to math.
Are we just confirming?
Yes, but I want to show you because there's often, you waste your time finding zeros if you don't need to. Number option for the absolute value brackets. Then I put in my 10 minus, isn't it? 10 minus 2t, yep. 2x in this. dx. 41 should come up. Yep, it's using some rounding, but it's pretty obvious it's 41, isn't it? Don't ask me what is why it has that imperfection 99994 or whatever. But it's 41. Now, the reason why I'm doing this is if you have some funky cosine equation, t to 3 halves and stuff like that, you don't necessarily, if it's a calculator section, you don't necessarily have to find all the zeros, unless it's specifically when was the object at a standstill. If you want the total distance traveled, use the absolute value brackets. If you just wanted what we had before, 0 to 9, and you took 10 minus, oh, not x, 2x. X, you should get the 9. And we do, right? You guys see the difference on your calculator? The absolute value is where it takes all the values and makes it positive. The absolute value has to be inside the integral. If I put absolute value outside and then put the integral in it, it'll still give you 9, won't it? Because it does the integral and then takes the absolute value. So that's no good. So just making sure you know. If you're going to use your calculator and you're allowed to, put it on the inside the absolute value brackets, okay? Lastly, the acceleration of the particle at time equals 5. What do you got to do for acceleration when you get to a velocity function? So v is equal to 10 minus 2t. Acceleration is dv by dt, which is 0 minus 2. Hey, I don't care what the time is, at any time, but in this case at 5 seconds, -2, but what's the unit? Meters per second every second, so meters per second squared. That means it's decreasing by 2 meters per second every second. The speed is decreasing by 2 meters per second every second, if you want to interpret that. Okay? I'm going to stop for this.